Hi guys, today we're going to be talking about probability. Probability. So there are two different types of probability that we're going to talk about. One is experimental. And the other is theoretical. So experimental probability, and first off, before we go into that, let's talk about the definition of probability. Probability measures how likely an event is to occur. How likely an event is to occur. So we can just say it's likelihood. So the probability of an impossible event is 0, and a certain event is 1. Okay, so we can express these also as percentages, 0%, 100%. Okay. When you gather data from observations, you can calculate experimental probability. So we're basically gathering data and trying to figure out how likely something is to happen. So the probability of an event equals the number of times the event occurs over the number of trials. Okay, so if you want to do this, let's look at a sample problem. So if you have a baseball player that gets a hit 5 times in 20 at-bats. So a baseball player gets a hit 5 times in 20 at-bats. Find the experimental probability of getting a hit. So the number of times the event occurs, which is a hit, that's 5 out of the total number of times, which is 20. The probability of getting a hit is 1 over 4. That's a simple example. One other thing we can do is we can do a simulation. So a simulation this is a model of an event. So let's just say we're picking a number between 1 and 6, so this would be simulating rolling a dice, a 6-sided dice. So if we look at an ordinary 6-sided dice, I'm not really sure how to draw one. Okay, we're simulating rolling a dice. So why don't we get our calculator? Okay. So the function I'm using is called random int. It generates a random integer between 1 and 6 inclusive. And each integer has an is equally likely. So this would be an example of simulating rolling a 6-sided dice. So let's just say we rolled it one time. We got a 5. Okay. So what we're going to do is we're going to do a dot plot of the values. So we can have 1, 2, 3, 4, 5, 6. So we got 1, 5. We did it again. We got a 1. And again, we got a 3, a 6, and a 2, 3, 6, 2, 5, 6, 2. And let's do it 2 more times. A 3 and a 1. So in this simulation, find the probability that you roll a 3. So the probability of rolling a 3 would be 2 out of, how many times did we roll the dice? 2, 4, 6, 8, 10. Which is 1 out of 5. Okay, so this is an example of simulating. Now, the next definition of probability is theoretical probability. In theoretical probability, we are dealing with the sample space. Okay, so in our example of rolling a dice, a die, you get the following is the sample space. It's the set of all possible outcomes. So we can have a 1, a 2, a 3, a 4, a 5, or a 6. So sample space is the set of possible outcomes. So for theoretical probability, if a sample space has n equally likely outcomes, and an event A occurs in m of those outcomes, then the theoretical probability of event A is m over n. So all that's saying is these are the total number of outcomes. And event A occurs in m of these outcomes. Then the probability is m over n. So this is your event. So let's try to use theoretical probability to find the probability of getting an even number. Okay? So when rolling a 6-sided dice, we know that these are our possible outcomes. So an even number occurs here, here, and here. So 3 out of the possible 6 outcomes represent the probability of an even number. Okay, let's move on to another topic. And that is the probability of multiple events. So here we have the probability of 2 events happening, A and B, and the probability of one or the other, probability A or B. So when we're talking about probabilities of 2 events happening, we have to define a few key terms: independent and dependent. When the outcome of one event affects the outcome of a second event, the 2 events are dependent. Outcome of one affects the other. So independent, when the outcome of one effect does not affect the outcome of the second event, the 2 events are independent. Outcome of one, and we gotta highlight this in red, does not affect the other. Okay, so let's do an example. So let's just say if we roll a number cube, a die, and then toss a coin. Rolling a die has no effect on tossing the coin, so these 2 are independent. A second example. So let's just say we draw a marble, or pick a card from a deck, and then we don't replace it. And then we pick a second card. Since I picked the first card and I didn't replace it, there's one less card to choose from when I pick the second card. So these 2 events are dependent, because choosing the first card affects choosing the second card. Okay. So let's quickly run through an example, or another rule. So if A and B are independent, the probability of A and the probability of A and B is probability of A times the probability of B. Again, this is assuming these are independent. Okay, looks like we've reached our time limit. We'll continue in the next lecture. Thanks for joining.